All right, welcome to this explainer. Look, if your AI agents are constantly hallucinating, or if they're getting stuck in these endless infinite loops and generating absolutely massive API bills, yeah, you are definitely not alone. And the truth is, it's highly likely because you're relying on a single model brain to do all the heavy lifting. We are way past the era of simple chatbots now. Today, we're building systems that actually work by setting up the ultimate AI dream team, the operator and the reviewer.
Think about this quote for a second. The day a finance team trusts in AI to handle their money is when AI has truly delivered. I love this because it brilliantly grounds all the current AI hype in a harsh, very relatable business reality. Today's AI systems are becoming genuinely agentic. We're trusting them with long-running, complex workflows, having them write enterprise-level code, and yes, literally handling company money. And when the stakes are that high, reliability is absolutely non-negotiable. You just can't afford to build a system that only works most of the time.
So let's get into Section 1, the threat, agentic drift, and infinite loops. So what exactly is agentic drift? Well, when you let a single AI model plan, delegate, and execute a multi-step task entirely on its own, without any external oversight, it eventually loses the plot. It gets confused during a long-running task, strays completely off the rails, and ultimately ruins the original objective. It's kind of like sending someone to the grocery store for milk and they come back 3 days later with a used car. The AI just completely drifts away from its core goal.
And when that drift happens, or when you try to brute force the solution using only the smartest, biggest model available, you hit a wall. Specifically, this number right here, 60x. This is the painful reality of API cost bloat. Routing incredibly simple, everyday tasks through a highly expensive reasoning model can cost 60 times more than necessary. It's a massive drain on your resources. And honestly, it happens simply because developers are treating all AI tasks as if they require the exact same level of heavy computational reasoning.
Which brings us to Section 2, the pivot, Bob the Builder and Ray the Reviewer.
Consider the editor-in-chief at LinkedIn. He successfully built a production-ready iOS app without actually writing complex code himself. And his secret? It wasn't just, better prompting. It was adopting a completely different management style for his AI. He created two distinct personas. On one side, you have the Bob the Builder mindset. This is your proactive, fast-moving creator. On the exact opposite side, you have the picky customer mindset, or Ray the Reviewer. Instead of managing the AI like standard software, he managed it like a real human team. He essentially pitted a highly proactive builder directly against a highly critical reviewer.
Let's break this down further in Section 3, Deep Dive, the Operator and Reviewer Framework. Notice how these roles starkly contrast with each other. On one hand, you've got the AI operator. This is the doer. Its primary goal is task execution and orchestration. It takes proactive, autonomous action. It focuses entirely on speed, throughput, and using tools to generate a completed draft. But then, right next to it, we have the AI reviewer, the judge. Its entire goal is quality control. It doesn't build, it evaluates. It focuses strictly on accuracy, maintaining brand voice, and mitigating risk, which results in a verified, corrected final output. So the fast operator handles the heavy lifting, while the methodical reviewer acts as the ultimate quality control gate.
But hold on, because here is Section 4, the cost trap, the danger of single model sourcing.
Listen, if you take away anything from this explainer today, let it be this. Using a single premium reasoning model for both your operator and your reviewer will absolutely bankrupt your project. Don't do it. Yes, the dual agent setup guarantees flawless output, for sure. But if you're using an outrageously expensive top-tier model to do the fast, repetitive execution work alongside the deep critical review work, you are walking blindly into a massive financial trap. So, how do we fix it? Section 5. The resolution. The model-agnostic dream team. It is officially time for the death of one-model thinking. For your System 1, your fast operator, you want a model with superior agentic capabilities, raw speed, and terminal control. A model in the GPT 5.5 class is perfect for this. It quickly crunches the code, uses browser tools, and drafts the initial work. But for your System 2, your deep reviewer, you need unmatched nuance, solid safety guardrails, and flawless editing loops. For that, we route the output to a Claude Opus 4.7 class model. Claude basically acts as the picky customer, critically evaluating GPT's work and fixing any logic gaps. You're pairing rival models' unique strengths together.
By utilizing an LLM router that classifies the difficulty of a prompt in mere milliseconds, you send the easy execution to the fast model and the really hard review to the deep model. And the hard data totally backs this up. This routed dual agent setup drops API cost by up to 70%, all without losing a single drop of quality. The fast model does the heavy lifting on the cheap, and the reviewer guarantees perfection at the end.
All right, let's get practical. Section 6, Actionable Takeaways, Building Your Dual Agent Engine.
Here are your 4 exact steps to perfect execution. Step 1. Separate orchestration from execution. You need to decouple the logic of coordinating tasks from the agents that are actually doing the work. Step 2. Use goal anchoring. Remember that agentic drift we talked about? Prevent it by pinning the original objective and using a secondary observer model to score every single action. Step 3. Implement parallel classification. Run your prompt difficulty router at the exact same time as your system prompt assembly. This gives you all the routing benefits with absolutely zero added latency. And finally, step 4, define your interface via JSON. Honestly, before you write a single prompt, lock down the exact JSON inputs and outputs so your operator and reviewer can communicate seamlessly.
Which leaves us with one final, incredibly important question to chew on today. What mission-critical workflows are you still trusting to a single flawed brain? One model thinking is officially dead. The future totally belongs to the operators and the reviewers working